And with that, I want to introduce Dr. Jay Simmons. He's the founder of Mach 30, a U.S. nonprofit organized in 2009 dedicated to the development of open source hardware for spaceflight. Jay was a project leader for Mach 30's open source Estes scale rocket motor test stand and for one of the first dedicated OSHWA project websites. Outside of his work in Mach 30, Jay runs a digital engineering consulting business utilizing his professional experience in the U.S. aerospace industry and his PhD in space systems engineering from the Air Force Institute of Technology. And with that, I will hand it over to Jay.
Thank you very much. Can you all hear me? Awesome. Thank you. So yeah, I'm Jay, and I have 3 problems standing in my way to get to open source hardware for spaceflight. And to put it quite bluntly, the rocket science is the least difficult of them to solve. Which begs the question, not is rocket science easy, but what are these other 2 things that are harder than rocket science? And as she said, I am Jay Simmons, and I want to talk about those other 2 things in particular. I'm a digital engineer. She mentioned my PhD. I consult on how to make systems engineering models talk to all the other models people are doing, whether they're at Northrop or Boeing or Lockheed or any of the plethora of other U.S. aerospace and defense companies. I am a staunch advocate of open source hardware. I've been participating in the summit since its inception. I did take a little bit of a break. I'm beyond grateful for an opportunity to come back and to get to speak on that opportunity. I have a couple of some of the inaugural certifications in a couple of my projects, both from Mach 30 and from personal work. And I speak whenever I get a chance about the importance of open source hardware, and I do as much open source hardware as I can. And it turns out I'm just an all-around geek. I like Star Wars. I like Star Trek. I like Stargate. I like Battlestar Galactica. I think there's a pattern here. Is anyone surprised that I became a rocket scientist professionally? Right? And in terms of introducing Mach 30, she's right. It's a 501c3. That's a charity organization in U.S. tax code speak. So we're a nonprofit, operate entirely off of donations and grants and volunteer time, with the mission to hasten the advancement of humanity into a spacefaring civilization. I will not be satisfied with the state of open source and rockets until you can design, build, test, and certify an open source spacecraft and then launch it and operate it via an open source launch vehicle. To say that that is a huge undertaking that will be way past my lifetime is an understatement, sadly. But that's what I mean by spacefaring civilization. We want space to be accessible to everyone. And we do that through open source hardware. So literally, open source plus rockets is what we're all about. As an example, US Certification 6 is the Shepard test stand. It's an educational project. I do not use this to test launch vehicle engines, sadly. I use it to test model rocket and motors. And the reason for this is multifold. First, it was a lovely scale project to test out what does it mean to do distributed open source hardware development across a continent. All of our developers were spread across the entire 4 time zones of the United States of America, some working in maker spaces, some working in their own home labs, some just grabbing Wi-Fi from their local coffee shop, right? And we put it all up there from the, we have an idea to do a thing all the way through the plans necessary to do the thing. And we learned a lot of lessons that I'm going to talk about in a moment. And I would be remiss if I came to an event and talked about rockets and didn't show you some fire and smoke. So here is the Shepard test stand operating. Notice tiny little Estes motor sitting in there. And then behind that is a load cell and an Arduino hooked to a computer to measure the performance, just like we would in a full-scale test stand. This makes it very accessible and much safer for new volunteers to come to understand what testing really looks like, what safe operations looks like. But it also means that it's good for outreach. I can go and take this thing to maker fairs and to schools and show it off and actually operate it, record real results in front of people in real time and go, That's what testing rockets looks like. So back to the 3 problems I have, right? Problem 1, export controls and open source hardware. And I know this is going to come up at least some from some of the other panelists, and I'm sure we'll discuss it a little bit. I hope, based on our prior conversation, we managed to avoid getting caught in a quagmire of export controls. But to be fair, why is this a big deal? Because for US folks in particular, but really anyone that is operating under legal regimes where export of munitions is regulated, which is a lot of us, just at different degrees, the very fact of publishing your plans as open source hardware constitutes an export, which means you didn't have to sell the design to someone. You merely had to provide it where they could get to it. And you are now running afoul of some of the legal questions, potentially. And so we are, at Mach 30, we are very cognizant of this, and we don't want to send any of our volunteers to jail by accident, which is a big problem. So this is a real thing. And several years ago, I came and spoke about some ideas we had to get around this, to at least operate within its restrictions. Today's not that talk. There are slides out there and content out there from that summit. I'm also happy to talk about it offline. But this, how do I publish absolutely everything about a launch vehicle ultimately, remember the vision that I just shared, when doing so looks like an export and could potentially get a lot of people in a lot of trouble? That's a huge problem. And I'm not a lawyer, I'm a rocket scientist, so it looks even bigger to me than it would to a lawyer, right? So this is my first biggest problem. And to be honest, right now, we just keep our projects below the threshold of constituting exports. If the sophistication is small enough, we don't hit those boundaries. And that's what we're doing for now, right? But that's what I mean by, something harder than rocket science, at least for me. And then the other is, how do we collectively, collaboratively, and distributively develop and share open source hardware? How many of you guys have open source hardware projects of your own? And how many of you guys have had to do revisions on the designs that you've published? Right? How quickly do things come out of alignment in your documentation when you do a revision like that? Yeah, I'm seeing some head nods, right? Instantly, yes, right? Blink or sneeze at an open source hardware project, half on GitHub, half in a wiki or markdown file, and half in CAD files, God knows where, right? And all of a sudden, everything's out of sync again. This makes it very difficult to collaboratively share, right? And we found that out the hard way. We did recognize that there weren't sufficient toolings very early on, so we did come and we proposed a Kickstarter to create a project that is the place where we hosted our stuff, and then we went and did it, and it broke anyway. So, and as we stepped away from that, we took away 3 big lessons. We said, you know what? Part of the problem is no one can quite agree on what the source of open source hardware is. It's very easy to point to what the source of software is. It's the code. Like, no one doubts that the stuff you write in C++, C#, TypeScript, Python, whatever, that you compile or run that makes your open source software become in existence and execute, no one doubts what the source of that is. The make files, the build descriptions, the Gradle files, whatever, your actual source code, any of the images and other things they need for icons. We all know what that is. But you talk about open source hardware, and it's a little more nebulous. I think there is slowly becoming some alignment, but not on how to capture it, especially not on how to capture in a way that will let you really, for the whole project, version and branch and fork and merge and do all the things that software developers, especially in the age of Git, are used to doing, right? That they take advantage of to share and multiply the leverage they have on their development experience. From teams of 2 to teams of 200. And then doing so also in a way where not only do I know what the source is, can I do the cool open source Gitty kind of things to it, but that I can say confidently that everything is in my project repository, whatever that looks like. So we said, these are the things you have to solve for. If you can't solve for those, you're going to still struggle. Is that fair? And so we then turned our full attention, as much as we like fire and smoke, as much as I wish I could build like three-step larger versions of Shepard, right? And test some high-powered rocketry equipment. We said, if we can't do it open source, we're not doing our mission. And so we have refocused our attention exclusively on solving that problem. And we're calling that solution the Distributed Open Source Hardware Framework, or DOF. And it has 4 guiding principles. The first is that whatever you decide the source is, whatever you finalize what the definition of the source is, we need to be running our open source projects and developing them and sharing them in accordance with the open source hardware definition from OSHWA. I don't think anyone's going to fight me on that. 2, that they should be developed and shared in accordance with the OSHWA proposed certification process so that we can easily certify our projects. Last time I went to do that, it still involved no small amount of wrangling of my data to ensure that I was delivering things in a format that met what the certification was asking for, not because it didn't exist, but because it was spread out and I had to make sure all was in alignment, right? So I want something that specifically includes gearing to make that easy, and that the whole process guides me towards doing that too, right? Because this is how I can claim credit and claim verification that I've really open sourced. We would argue, back to that branch fork merge business, we want to ensure that open source hardware development has as much of the look and feel and experience for the developers as possible to open source software. We want to learn their lessons. We want to take advantage of what they have done and what they show us, because that's where success comes from. These people didn't make this up out of thin air. They've earned their lessons and processes over decades of experience. And let's cheat and copy off their test. And then finally, along similar lines, let's leverage existing tooling instead of making brand new tooling to the greatest extent possible. If somebody already figured out in open source software how to do a thing like, say, package management, and it worked, and we can make it work for us, I would rather make their thing work for us than start from scratch on inventing a whole new package manager and repository system for it. As an example, version control, same thing, right? And if you want to see more of what we're doing specifically to address this, there's 2 links here. The first is the results of a workshop we ran about 5 or 6 months ago, soliciting feedback from open source hardware developers at another conference. I think it was something similar to Scale, but in Washington State in the US. So you go there and you can see a report of a bunch of user stories that the community contributed to us. They said, these are the things we really care about. These are the things we wish were easier or better or were possible at all. And then the second link, feel free to take photos of this, find it on the website. The second link is a video of the year before, I think it was, when I did a talk all about these goals and how we want to achieve them at Scale in California, the Southern California Linux Expo. And in the interest of getting to actually talk in the panel with each other as opposed to talking at you guys, I will stop there and bid you ad astra per civitatem, which is Mach 30's motto, to the stars through community. Thank you.
Oh my God, I also have this problem. We all need to solve it together because we're all going to solve it on our own. All right, so, which would be even worse. Next up, we have Logan Herrera, correct? Okay, good. Logan is an electrical engineer by training and leads the Lander Challenge Self-Landing Rocket Challenge compliance and has been launching rockets for over 15 years. He's passionate about rocket engineering as a multidisciplinary educational tool, having mentored numerous student teams and developed open source information sharing approaches to foster academic innovation. In addition, he serves as the director of media for the International Rocket Engineering Competition, IREC, the world's largest university rocket engineering competition. In this capacity, he successfully led a public engagement campaign that generated unprecedented community participation in U.S. export control reform, resulting in over 2,200 public comments. And I'll turn it over to you, Logan.
Great, thank you. Thank you everyone for being here, and thank you, Jay. I can see why we were put on a panel together. I'm going to zoom in a bit on the export control problem here and tell you a story of how we had some success with this with the lander challenge. So setting the stage, what is the lander challenge? So the lander challenge is a set of rocket performance milestones. It's designed for universities anywhere in the world. There are cash prizes. If you achieve these things, then you get a giant check in the mail. There are a few technical requirements, minimum rocket sizes, and also key for this open source sharing context is you have to make media about your milestone attempts, and you have to publish your designs. The first 3 teams to reach these milestones win the prize. So far, all of the engine prizes have been claimed. And I'm hoping to see some hovers coming up in the fall. And we've been at this for about 2 years now, and the competition or the prize pool is open for another 2, unless it gets extended. We'll see. So to give you a sense of the size of rockets involved here, this is Purdue's rocket engine throttling, so you can see it going down, and then it will come back up. There we go. So congrats to them, and that was the most recent throttled hot fire winner. Oops. There we go. So we've got teams from around the world participating in this. We're now at over 20. We're a US-based organization, and most of the teams by number are in the US, but there are teams from around the world, right, including Imperial College London, Monash in Australia, TUM in Munich, and so on. But in the beginning, and you may say now, but what about ITAR? This was a big obstacle for us in the beginning. I think there was this idea that all of the custom engines and rockets students were building at universities were okay, but this self-landing thing where you're coming up, coming back down and landing is too much. That's too far, and you're in a new world where that's not allowed. The key idea behind this is dealing with export control, right? The International Traffic in Arms regulations they're US regulation administered by the US State Department with potential criminal penalties. So there's a big potential downside for conviction for violating, and it's the most well-known one that gets the most attention on it. However, there are other versions in other countries around the world. We found that students were really intimidated about this, that there was a lot of concern or fear that people weren't really able to articulate exactly what the problem was, but it's definitely bad, and I should stay away. And just going into the definition of export control, right? What is that? It's restricting the movement of physical stuff across borders, and it's restricting the flow of information across borders. And so in order to stop things from moving across borders, you have to define what's the thing that can't move. And this is pretty important for the projects here, right? Is first step when you're working on a project is figuring out, am I controlled or not? Do I need to be worried or not? And you have to go and read the list, the big long lists of what is controlled. And I think this was the first step that if you go and actually read the list, you are ahead of 90% of people in understanding export control. So one of the things I would really like you to do is, if you are worried about this in your own project or in your own context, go find the relevant list and actually read it. I think it will put you far ahead and have a lot more confidence in dealing with this compared to the feelings that can swirl. The most relevant international regimes for rockets are the Missile Technology Control Regime and the Wassenaar Arrangement. These are they're kind of informal political understandings. They're not quite treaties, but it's a group of countries that have all agreed that we want to do basically the same thing. It started with the G7 and has grown beyond that, but it does not cover the entire world. Notably, Brazil and Mexico are members of only one. China, the Philippines, and a lot of countries in the Middle East also do not participate, but it's relevant to many countries in Europe, for example. And in general, even if they're not participating, even if your country is not participating in this exact pair of lists, there's probably some kind of something that's relevant to you. The key performance criteria for all of these is a rocket that can carry a 500 kilogram payload through to 300 kilometers range or technical relevance to that threshold. So that's basically the minimum scope of these controls in general as a trend. And that's quite a lot of payload a long way, right? That's quite a lot compared to what the amateurs and I know are interested in. So if you read the list, you might find that what you're working on is not controlled. However, for this challenge in the US, it tends to end up controlled based on exactly how you're implementing. And so one of the places I have a message of good news is that universities in particular are specially privileged in export control. Universities still have to control the physical stuff and make sure it doesn't leave the country, either on purpose or by accident. And then the research itself doesn't produce controlled information. So as from a policy perspective, countries want their universities to be producing new knowledge, to be giving them the cutting edge, to be world leading, and have generally made the policy decision that they want to control the physical stuff that's relevant to militaries, but they don't want to stifle university research. And so as a result, the US certainly, and a lot of countries generally, have placed special carve-outs for universities to give them special privileges. And so where we landed with Lantern Challenge, to help get people more comfortable to win the hearts and minds and give some insight into how to exist under the current regulatory framework, as we went out and we spent a lot of time with multiple law firms and wrote some guidance, some suggestions on how to deal with this, some frameworks that you could take to your own university and figure out how to make some progress on this to dispel the fear and do it the right way, understanding what you do need to do and not being afraid of unnecessary things. And some of those highlights are: read the list and determine if your project is actually subject to controls. If it's not, you can stop here and don't have to worry about anything else. If it is, structure your project as research and publish the results openly. This is a place where secrecy is harmful, not helpful. There's often a reflex to keep things secret to yourself. If no one knows, it's fine. In fact, for all of these exemptions, doing research requires publishing openly as part of the definition. A gotcha is don't accept controlled information from vendors. If you are buying something to use in your rocket, that's a common gotcha. The fact that you are doing research does not uncontrol something you bought. So you have to be careful about what you bring into your research, and so you don't contaminate it with controlled information, and secure your physical objects. So those are some highlights from that guidance, which is available on our site. I'll have a QR code at the end. I have less good news for everyone else who is not in a university context. In the US, there are these concepts of public domain, of if it's already well known or already taught in universities, then the information isn't controlled. But if you're doing something interesting and new, it can be challenging to argue that these apply. And exactly where that line is not very well defined. It hasn't been extensively litigated. So it's a little difficult to take advantage of those. It is theoretically possible for the government to pre-publication review in the US. No one has ever actually done that I know of, or any legal counsel I've ever talked to does not know anybody who's ever done this. So I would love for somebody to try this process and see what happens. But right now, it's just a theoretical possibility. So where are we now? So after spending the time working on this and getting this guidance together and consulting with the legal team and meeting with a lot of university export control officers and doing the hearts and mind work to get people onto this consensus on top of the legal work, right? We've released this to the public. We invite you to read it and to make use of it in your own contexts and remix it. The universities participating in this have taken full advantage of it and are feeling good about it and are underway, winning prizes, building rockets and winning prizes. I also want you to take away that export control is a political and regulatory process. You can participate and advocate. So all of this guidance is how do you exist under the current system? The system is malleable, and you tend to underestimate what you can do in a year. No, it's the other way. Overestimate what you can do in a year and underestimate what you can do in many years or a decade on this. That is not instant, but it is profound. I think notably spacecraft were almost completely came off the list in, I think it was 2015 or so, Obama era in the US. Right now, rockets are undergoing regulatory reform in the US. And you can influence it, and it tends to be a very technocratic type process where specific technical insight and experience is valued. So there is no magic way to do it. It requires work and building consensus and submitting public comments in concert with many other people. But you can do it. And I encourage everyone here to participate in the regulatory process wherever they live, because we can work under the existing system, but we also need to be advocating to change the system to most accurately reflect the frontier of technology today and what is worth controlling and what should not be controlled. I'm happy to talk to you if you would like some ideas about how to do that in your own context. So here are the QR codes for the Lander Challenge overall and that ITAR guidance specifically for anybody who wants to learn more.
Great work. All right. And all right, you ready, Joe?
Yeah, hey, we've skipped a slide, but we'll not go back, so that's okay.
All right. All right. Well, I will introduce Joe Hinchliffe. Joe is a freelance maker and technical writer with a focus on open source technologies. His clients include Raspberry Pi, Tindy, the FreeCAD project, RS Electronics, Tom's Hardware, and more. Joe sat on the UK Rocketry Council for numerous years and was a core contributor to the Libra Space Foundation and holds a UK altitude record for A-impulse rocketry. He has designed and delivered many rocketry workshops and mentored rocketry teams and individuals in the UK. He's a founding member of the Flame Trench, a collaborative group including Joe Bernard and Arsenio Menendez. I'll turn it over to you, Joe.
Thank you very much. So I'm not going to talk about export control, but I went. Oh, I didn't. It's a very valid subject. So yeah, I'm a wibbly wobbly freelance maker, work in lots of different sectors and do lots and lots of different things. And when I was sort of approached about changing my application for a talking to a panel, which is this, they asked us to come up with like 3 questions. So my last slide is 3 questions, and the 3 questions are about open source rocketry, and they're questions kind of I want you to help me answer. That'd be good. But the stories I'm going to tell in my talk are not all to do with open source rocketry. They're all to do with open source, and there is a lot of rocketry in it. They all kind of link to space. Also, there was quite an early deadline for putting some slides in the Google Drive. So I didn't have that much time. So I put in like all the slides I own and then never return to them. So there will be ones that I just go, yeah, ignore, ignore, ignore. So yeah, my main way of earning a very meager living is I write for people, those people that Kat just read off the list. So yeah, I've got a couple of books out just flexing my kind of open source kind of hardware kind of stuff in front of you. So I wrote the FreeCAD for makers. So FreeCAD is like open source mechanical engineering package. I do a bit of work for them as well. So if you want to talk to me about FreeCAD and get stickers, come see me afterwards. And this book is free to download on the Raspberry Pi Press. You can download that book if you can get through the first 2 chapters. I didn't say that like it's not hard to get through the first 2 chapters. You get through the first 2 chapters, and then you're knowledgeable enough to jump to any other project in the thing and be dangerous. And then I also did a Design an RP2040 board with KiCad. That is, oh, we're streaming, aren't we? That's a brilliant title. I love it. I really applaud the title. Yeah, it's a bit of a misnomer. It's basically a KiCad book, and it's how to get started with KiCad book, but it's steps people through how to do a PCBA, so where you get your design made and manufactured by a company and delivered to you as a product. So yeah, that's kind of some of my work. Oh, I've clicked things. There we go. When I'm not writing, I'm running lots of rocketry workshops. And so this is me. I come from North Wales. I live in a little hamlet, and even in my hamlet, about a couple of months ago, I managed to get 11 people with an age range of 9 to 81 in a room, and they all designed and simulated a rocket using open source hardware. And it was a rocket, and it was like feasible. They could go away from that and buy components or make tubes and things, and they could build the rockets. So I do a lot of that. I also have, this is quite a small rocket, and it's an open source design that's hexagonal, and I build it using a vinyl cutter, which is not really meant for building rocket parts. It's a tiny thing. I sell them on Tildy, and it's actually the first rocket that I put through the OSHWA certification thing, so it's the UK 64th one. Weirdly, I didn't realize at the time, it's actually OSHWA's first ever open source rocket that's passed certification. Hey, there we go. Who knew? Thank you. Oh, you're very good. This is another open source rocket of mine, and this is like a sort of an aspirational thing. For these guys over here, this is not like it's a pretty nice looking rocket, but it's nothing particularly special. It's kind of in amateur rocketry world, it's what people do for like a level 1, level 2 type rocket, which is where as you're stepping up in power. But I open sourced the design. So that means that I put the design files for all the components that I CNC milled in it. I put the 3D printable parts on it. I described which brand of phenolic tubes I used to make it. And, you know, the Inkscape drawings of the fins are on there. And so it's completely sort of open tool chain and open source. And it's the sort of rocket you'd fly up to like maybe, I don't know, 4,000 feet to maybe 6,000 feet, maybe 8,000 feet on an expensive motor. And yeah, what's really interesting about that is that I open sourced it, not really expecting people to go off and make it, but it was just more about, I wanted to start that story in motion, that it's on GitHub, like there's a rocket on GitHub. And it's like, I just wanted that narrative out there. The interesting thing about that is that it's been used for research rocketry. Because actually there's a really interesting thing that I didn't really realize until I started going to high power rocket events, that between like 4,000 and 10,000 feet in the UK anyway, that's quite an expensive bit of air to get to. It's too high for RC planes and drones, and it's really expensive to rent a helicopter to go and hold your air quality, or, you know, your particulate sensor. And so actually, interestingly, at like maybe, I don't know, 60 to 80 UK pounds a flight, this carried some air quality measuring tools for some people to an interesting sort of strata of atmosphere that's actually quite difficult to get through by other means. I also do teeny tiny ones. So that one's about this big, and this is the rocket that holds the currently still holds, unbelievably, a UK altitude record on the smallest sort of commercially available rocket motor that you can buy. It's ridiculous because I didn't open source the design. Ooh. Thank you. Yes, curse me. But what I did was I did a blog post talking about how I'd beaten the guy just below me, who now, out of interest, owns quite a snazzy rocketry company in the UK. And I sort of described how I'd kind of beaten him. And it's basically, I did a load of mass reduction. But also I gave loads of tips as to how somebody could beat that record. And interestingly, there's a guy in the south of the UK who has done it, but he failed to get his paperwork right. So I'm still the record holder due to an administrative nightmare. And yet I've managed to sort of slide my professional life into things that fly and explode and blow apart. So there's a thing in like some rocketry communities where people build rocket gliders. So all those wings fold away, it flies up vertically like a rocket, and then at the top it explodes a little bit and pops its wings out and sort of flies back down to Earth, hopefully close to you. Sometimes. Anyway, and it's an open source design. And I kind of like the opportunity to write these stories because I don't think many people are going to pick up a copy of Hackspace magazine or read it on RS Electronics and go off and do it. But I think it's really interesting about giving people permission to play with this stuff. But what led me here? This man led me here, a conceptual artist from South Korea. I should have explained at the beginning. I have no education. I was dragged up, right? I have no education. I've never been to university, none of all that stuff. So this guy inspired me. In 2014, I'd finished building a miniature self-designed modular synthesizer that only used CMOS 4000 series ICs, which were never designed for audio. And I'd made it as an homage to a New York artist called Stanley Lunetta from the 1960s. And that's kind of what I was into. And I finished it and I was like, oh, I don't know what to do now. I'm bored. And I was like, what's my next project going to be? Oh, I don't know. I know a bit about electronics now. I know how to solder. I know a bit of this, that. And I came across this guy. This guy's called Ho-Jun Song. He's a conceptual artist. His previous project to this was building an iceberg in a shopping mall. What he was doing, though, was he launched this project called Aussie. And Aussie is a CubeSat satellite. We've got some CubeSat builders in the room. Okay. And a CubeSat is a form factor. We heard about it yesterday, like Quetzal. It's a unit size of satellites. And this guy was like me. He wasn't an engineer. He wasn't a developer. He wasn't a coder. He wasn't a hardware guy. He'd done a bit of soldering. He'd made an iceberg in a shopping mall. And the logical next step was to start building spaceships. And his whole narrative was science as art and science as fantasy. And it's okay to fantasize about this stuff, but actually move beyond fantasy and start building the things that you want to build. And he did it. And it was kind of pre-crowdsourcing. There's a weird slide I probably haven't put in here, of where I was the first person to send him some money from the UK to South Korea, which was a bit tricky at the time. And he sent me a message, which I screenshot, because it said, I think you're the first person to, as a private individual, to sponsor a private individual amateur satellite. And I was like, oh, okay, that's weird. I'm probably never getting that t-shirt, and I never did. About that time, so this is like 2013, there's another emergent form of satellite in 2013 called Pocket Cube, which was 1/4 of the size of a CubeSat, so 50mm cubes. I got obsessed with these. I built a little model that is essentially on the bottom is an Arduino, and on the top is an actual space-rated radio that's made in the UK by a company called Radiometrics that's flown in low Earth orbit. And I built this to take to maker fairs and hacker events, and I could have a bit of software, a bit of SDR dongle, a radio connected to a laptop on one end of the desk and that on the other, and I could do demonstrations about how satellites work, and also talk about the Pocket Cube form factor. And this is before any of the Pocket Cubes had ever launched. And so there's loads of stuff wrong with this. Like, this would never, ever make it anywhere near space. I mean, it barely made it off my desk into a bag, you know? But interestingly, like, it gave you, it gave this permission and this tantalizing flavor of this stuff is within reach for people. Weirdly, the space-rated radio is what happens when you ring up a company and say, can I get a free sample? And they're like, no, we don't do free samples. They're very expensive. And I was like, oh, okay. And they go, who are you? And you go, oh, I'm just a bloke in a shed in Wales. And they laugh and they're like, we'll send you some samples. Like, you're kind of one of us, you know. At the same time, I got into, people were really struggling in the nascent Pocket Cube scene. And remember, none of these had launched. It was all just a concept. And there was like 4 of us in the world talking about these. People were finding it really difficult to work out how to make the chassis within the tolerance so that they could actually pass the inspection. And sort of, I was really invested in doing that with like cheap kind of maker level tools. So like the kind of little CNC mills you might find in maker spaces and stuff like that. So yeah, I was being gobby. I got asked to do a TED talk about Pocket Cubes, which involves this horrible picture of me pre-beard, holding a small cube and looking like I'm about to eat something. So people got interested in Pocket Cube. Around the same time, I fell in with a bad crowd. Does anybody know this crowd, LibreSpace Foundation? Yeah, some dodgy. No, they're brilliant. They're brilliant. So if you don't know about LibreSpace, and I promise this does bear some relevance to the questions at the end. LibreSpace came out of a NASA Space Apps Challenge, which is where people can join a global hackathon and run a local team. And they ran one in Athens, and I sort of went in virtually on like VoIP calls. This is like 2014, so I don't know what that platform was. It would probably be Skype or something dreadful. And one of the themes that year was satellite communications. And out of it, this isn't what we built that weekend, but what came out of it was a thing called SatNogs. And SatNogs is a Raspberry Pi project that connects to like a really nice web end and a database. And it's like a decentralized network of ground stations that we can all schedule to listen for satellites, and we can decode and get their telemetry. And so, yeah, that's my station from a few years ago. That's where I live in North Wales. I'm not doxing myself too bad. I don't think you're going to turn up at my house. Yeah, and that's my call sign up there, MW6 Charlie Yankee Kilo. And yeah, so that's mine. But so that was 2014. Cut to sort of the end of 2014. This is, when Quetzal spoke yesterday and they built their one ground station on their university, they would get like one line like this above their pass, maybe, and they can see their satellite for like maybe 90 seconds, maybe 30 seconds. Hopefully they can point their stuff at it and slurp off some radio data. What the decentralized network of SatNogs did, all by amateurs building these little less than $100 or maybe $200 if you did some fancy moving stuff, rigs in their back gardens, was it gave us near global coverage on certain frequencies. So this is like what you could then expect from like one satellite passing around the Earth in a week. So at this point, it tipped over that for UHF and VHF and certain applications, we had way better coverage than NASA, ESA, all this stuff put together through open source and through individual self-determined sort of project stuff. Cool, yeah? Super cool. So as such, in 2015, we won the Hackaday Prize. I'm like trading on 10-year-old accomplishments. That's a really bad flex. Anyway, yeah, we won the Hackaday Prize. It was a good year to win it because the prize was either a commercial ticket to space when one became available in the future, or what they worked out as the cash equivalent at the time. And the cash equivalent at the time was like a couple of $100,000. So we took the money and we ran away. No, what we actually did was SatNogs became the first project under an umbrella organization called the LibreSpace Foundation. And the first thing we built was a 3-unit CubeSat called UPSat because we had the ground station system. So why wouldn't we build the spaceship that we could send up there? And then, so we built that using the money that we won in the Hackaday Prize. So like developers got paid. So this is what, it's the first open source hardware CubeSat. In terms of it used all that kind of modern stuff that you would recognize, like it's on repos and like everything is there. And it's sort of like a lot of the AMSAT guys say, oh, we've been open, and they have, but it's been like you have to go and ask Derek like to pull out the folder from it. And well, what we did was I drilled through this, and then so like it's just a sort of different era of open source. Not necessarily better, not necessarily worse, no judgments, but it is what it is. So we built that, and then you send it off, you do all the kind of tests on it, and you send it off, and it went up on an Atlas V after 5 months of it being sat in there, and everybody in the community going, did I solder that thing on? I don't know. Did we charge that battery? So it's sat there for about 6 months. And then this is the actual ship. So it's up there in that Cygnus resupply module. It's up there, and it got blasted off up to the International Space Station in early 2018. And then this is an animation that doesn't work. So what we did for those 6 months while we were all worrying is we also contacted the astronauts, and they took lovely photographs. And we've got a GIF, but it doesn't play. So what you've got to imagine, a little box comes out of there and goes, that's it. Thank you. Yeah, so it deployed, and a reasonably successful mission. Some things worked on orbit, some things didn't. that led to us getting a lot of attention, the Libre Space Foundation. So we ended up getting invited to like run events at like European Space Agency locales. So this is one of the open source CubeSat workshops that we helped host in Darmstadt, which is the operation centers for ESA missions out in Germany. I'm handily at the back, not looking at the camera, trying to steal that big rocket. Yeah. And that's me looking really nervous about to go on stage. Oh, and at the time, I met this other guy. This is a guy called Rakesh. That is me without a beard. Unbelievable, I know. And Rakesh was getting into building pocket cubes. And I became a big advocate for Rakesh, started giving him some like technical help with his pocket cube, but also just became a gobby advocate. Rakesh is a very humble Buddhist man from Nepal, who became an engineer from the University of Kathmandu, ended up in Switzerland, earning a decent living, working for a closed-source medical company. He sends most of his wages back to Nepal and has set up a program called Orion Space back in his university. And undergraduates get the chance to work on real space hardware that goes to space within their 3-year tenure at the university. Rakesh is incredibly humble, but needed money and support. I am incredibly not humble and gobby and would stand up and say, everybody give Rakesh money. Go and talk to Rakesh. And so I did quite a lot of, I play it down, but I did quite a lot of like sort of community development for Orion Space. And then cut to a few years later, 2019, they launched Nepal's first satellite. Was built by Kathmandu University. It's a pocket cube, it fits in your pocket. And they put all the contributors' names on the bottom. And they were so appalled that my first name only has 2 letters, they insisted on putting my surname as well, like the only person. So there we go. Flew on orbit really beautifully. Back to rockets. So rockets, there's a really old open source bit of software in rocketry called Open Rocket. What Open Rocket allows you to do is design and simulate rockets. And it does a thing called an advanced set of the Barrowman equations, which you can do by hand, but you drink a lot of coffee and you put a lot of wear and tear on your calculator. Open Rocket has nice things in it, like it has a database of all the known components, and it's all completely open source. So all the sort of commercially available components for model, mid-power, high-power, amateur, and sort of butting up towards like kind of the stuff that might get used for like research rocketry. All the commercial components are in a database, and yeah, you can do things like you can solve things like the stability of the rocket design is kind of automatically calculated, which replaces the need to do those complex equations. And you can do things like you get a simulation that looks like this, that shows like the various speeds and thrust curves and the altitudes. And this one has 2 lines because it's coming down. There's 2 stages coming down separately under 2 different recovery systems. There's other open source tools that allow you to, when new motors come out on the market. So in Europe, there's a new manufacturer called TSP who's creating some smaller motors. If they produce like a visual graph of their thrust curve of their motor, people like me can sort of act as librarian contributions. So what I do is I use this tool to trace over their thrust curve, and I can actually generate a file called an ENG file, which can get plugged back into Open Rocket so that we can use those motors on our simulations. And whilst this all might look like kind of lower end model stuff, it's actually really slick. So this is a project in the States called Mojave Sphinx by Half Cat Rocketry, completely open source and incredibly well documented. If you're at all interested in sort of some of the higher end, bigger stuff of amateur and sort of open rocketry, this is a great read to go away and have a research. It's a bipropellant liquid rocket engine capable of like sort of 20 kilometers of high flight, really, really well documented. They use Open Rocket. They worked out, they put their biprop motor engine on a test stand, worked out all the thrust curves, pulled it all into Open Rocket, and used Open Rocket to work out their flight dynamics and stuff. I also work for FreeCAD, and I'm involved in FreeCAD, and I've used this Open Rocket tool for a long time, and I thought, do you know what, it'd be really good if there was something in FreeCAD that could help me make the parts, because what Open Rocket doesn't do is it doesn't spit out like object files for me to 3D print or CAM or stuff like that to make the parts. So I thought it'd be really cool if like there was a tool set in FreeCAD that made that a little bit easier. And so in a sneaky act of community development, I did. This is the way I approached it. I kind of put my idea up on the FreeCAD rocketry community. And first of all, I paid my dues. So I'm not a dev, so I don't know how to build this. So I first of all, massive thanks to the dev and the community for an amazing project. FreeCAD rocks. I'm proud to use it, blah, 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 blah. And then I kind of got into the stuff I do with rocketry and the idea I had for a workbench, which was, what if we could pull our files from OpenRocket into FreeCAD and it would build our rocket in there, and then it would chuck out like printable geometry and stuff like that. But I don't know how to do this. Wonderful thing is I made sure a man I met saw this thread who I suspected could build this, and my trap worked. So Dave Carter in Canada, I'm sorry I've ruined your retirement, but them's the breaks. Yeah, so, and the wonderful thing is, though, is that he said, oh, you know, I'm kind of curious, convince me why this is needed. So I did. And then by the time we'd had that conversation on the forum, the rest of the community started jumping in and started saying, oh, that thing you don't know, this is how that works. This is how this works. This is how this works. Cut to the chase. That's the first iteration of a rocket workbench, which is a free and open source add-on to FreeCAD. I can now pull in my open rocket design for any rocket, whether it's 10 meters tall or whether it's 20 centimeters tall, and it will build it in CAD. Remember that database? Well, it's all there. In fact, the database is now better because a lot of the FreeCAD people have started updating the database that's in OpenRocket. So if you have a little rocket that you had when you were a child and you've lost the nose cone, you can find it on the big list and click like 2 buttons and you can have a 3D printable file of any of those nose cones that exist out there. It's made a really interesting on-ramp for me as a community engagement person to get people in the rocketry community who've never used CAD before excited about it. So one thing rocketry people, I'm going to say people, but it is usually guys, but people like to do is they like to take a really small rocket that they really like and build like an upscale version of it. Now, what this actually is, if you ask my partner what that is, it's like taking a £10 note or $10 note and then adding like 600 or 700 more of those to a pile and moving it over here and just setting fire to it over here as opposed to there. That's kind of, it gets expensive. But the interesting thing is that, of course, this tool plugs into FreeCAD. FreeCAD's got all kinds of CAD tools as a rich and varied CAD environment. So if you have a nose cone off that thing, you can go over to a different workbench, learn how the drafting tools work, and you can scale that nose cone up in like 3 clicks. That's incredibly powerful for rocketry people to kind of see if they've not used CAD before. And of course, it's the gateway drug. That's the first bit. The next thing is people start saying, oh, if I learn some of the other open source CAD techniques, I can start adding other bits of geometry onto my parts. But also, it may still sound like this is all kind of like model scale and not very sort of super exciting to industry. But in the test branches, what FreeCAD has this huge sort of workbench that deals with computational fluid dynamics. And I would say, I am biased, but I would say it's probably the easiest way to set up a tool chain using things like OpenFoam and SimpleFoam and other computational fluid dynamics solvers. Don't worry if you don't know what any of that means. But basically, I would say that this is one of the simplest ways to set up this very complex system for analysis. And so built into the Rocket Workbench now are things like fin flutter analysis, which is as your rocket transitions through the sound barrier, its fins are going to flap about. And if you overbuild them, it may never get to the sound barrier because it'll be too heavy and too draggy. But if you underbuild them, they'll flap off and everybody will die. No, it'll all fall out of the sky and it won't be good. And so this tool is like now sort of, it's not quite 10 clicks away, but it's coming that it's going to be very, very matter of fact to apply this very advanced type of sort of analysis to specific parts of rocket airframes. And that starts to garner the attention of people like the European Space Agency, and actually industry rocket designers are now starting to appear on our forums going, okay, what's the roadmap on this feature? What's the roadmap on that feature? As a sly aside, I've just launched an experimental magazine, and the first test issue, which is a suggested donate what you feel of £3, is 11 pages, all about how to set up a computational fluid dynamics environment in FreeCAD. If you want to find it, it's on the line. It's online somewhere, and you can share it. It's so open, you don't even have to you can put it on your own website and share it and all that kind of stuff. We're running out of time. One last inspiring thing. Okay, so in a FreeCAD development meeting, this guy turned up from the UK Advanced Manufacturing Research Institute, which is where UK government, we're live streaming, so I've got to be really careful. It's where the UK government pours money that it seems to pull off a magical tree, and it doesn't necessarily always care about the results that it gets out of there. I'm sure around certainly Western Northern Hemisphere, I've seen lots of innovation centres like this. They had a project that was funded partly by government, partly by Boeing, which is, I'm not going to put a picture up of the machine, but it's like 2 6-degree of freedom robotic arms wrapping carbon fibre around a CNC lathe, and it's doing super clever carbon fiber filament vessels and shapes like rocket nose cones, but in more complex geometry than has previously been sort of available to do in that sector. And the interesting thing there for me, and I promise this does relate to rocketry, is that they initially they had nothing that could visualize the toolpath and calculate and do the CAM, the computer aided machining aspects of this. And they actually asked the question, so all their academics, like most in the UK, have come up through university on an engineering degree, and they know about Fusion 360 and they know about SolidWorks, okay? And so they thought, okay, we'll ask Autodesk to build this. And well, it was like, tens of millions of dollars to build an interface for this machine that would involve them giving the entire machine to a locked vault in Birmingham for 2 years. And then they would get they'd still have to pay for a license to use the tool they paid to develop after it. So this guy here, Julian Todd, a great, fantastic UK hacker maker guy who contributes to FreeCAD, said, just do it in FreeCAD. It's all open. There's already loads of CAM stuff there. Like, you can just build it. Like, your undergraduates can get stuck in here. You can lift the lid off, which you can't do in like Fusion. And so for me, I was completely inspired by this. So that's the project there. That now, like, this really, really high-end project is chucking out kind of interesting high-end innovation, all based off like open source tooling. Which led me, I've missed it. Which led me to, I built an open source desktop carbon fiber filament winder just so that I could use the FreeCAD plugin to make it move up and down, because I wanted to acknowledge that they'd done that work. So that's called Filler Winder if you want to wind some carbon fiber tubes for your own rocketry stuff. Yeah, so to the question. So the thing I find interesting about rocketry is the Libre Space Foundation are now at a point where they take contracts from the European Space Agency to develop stuff that they're interested towards space using open source hardware development models. Work going on in hack spaces around the world that they fund on behalf of the European Space Agency. And yet, rocketry we seem to focus on repeatedly running competitions where people build rockets that have to fly to like 10,000 feet. We have aspirations to become a big rocket company. That's really common to meet young people at rocketry events and potentially young men, and they kind of all they want to do is like, I want to be Elon Musk and I want to build a rocket that goes to space. And it's kind of cool, and there's loads of engineering stuff that we can build onto that exciting narrative for them. But I question whether that's where the viable stuff is. So this image is a proposal that was part of a funding project that any organization, including any open source organization, could have applied for, which was about building a rocket for a Mars sample return mission. And so quite a small rocket working in a different atmosphere. We could use all that nice computational fluid dynamics stuff and set it up for Mars. That would be sexy. Sorry, I shared too much about my kinks. And it intrigues me that we don't sort of move towards this stuff as a community. So these are my panel questions that I would like to explore and have answers. What do the next levels of open source rocketry look like? What are the next levels of open source tools for rockets and propulsion? And how can open source interaction happen around such specifically localized activity? Are are my questions, but we don't have to answer those. But we can if we like. I shall shut up.
All right. I will ask all of our speakers to come sit over here. And I will switch over the camera so the live screen can see them. Where is the live stream?
Oh, do you want it against the wall?
Yeah, well, so there's if I do this, the live stream will see you. There's a magic button. Okay, so let's see. Why don't I start? I'll start with an easy question. I'll turn it over to you guys. So, like, open hardware LEO when? in the history of making bad predictions about space travel. Come up with a number right now, and we're holding you to it.
I don't know. Lower bound, end of my lifetime. Upper bound, 2 generations, grandchildren's lifetime.
So the sad thing about this question is that you're talking about reproducing work done in the 1950s, because it doesn't have to be modern. Like, remember how much difference there is between modern launch vehicles and the launch vehicle that put Sputnik in orbit, right? Or the Redstone and the original Atlas rocket. So the sad thing is, you may not be far off, not because of the technological limitation. Like I said, the rocket science, that is the relatively easy part here, because I can send people to school on rocket science and they will come out with knowledge necessary to do the math. I can look at shops that build parts today and they can build parts that are openly licensed. The hard thing is all these other things hanging around it and the will to do it. And yeah, I would be shocked if we had open source LEO within at least my professional lifetime and possibly my lifetime. And it shouldn't be that way technically. The thing stopping us is political and cultural and people, not technology.
I agree totally. I think the timeframes are probably what I would say. But my slightly maverick answer is I don't perhaps think we should. And that's not to say we shouldn't look to democratize space and look to have open source launch vehicles per se. But it's that thing of like, there's a thing I read in a paper that if we didn't have Starlink and OneWeb, we could actually have saved enough carbon to actually have a visible, it may be at like 6 digits after the decimal point, but have a visible change in carbon and climate change. And it's like those two services, when you look at them on paper, if you take all the how much things cost and how much internet you want, they're essentially a similar service. They're like internet in space, and if we had the big social change that I think that we need as a planet to kind of overcome some of the problems we face, you wouldn't have Starlink and you wouldn't have OneWeb. You'd have one of them or something else. And so I kind of think I love rocketry, but I'm appalled by the amount of carbon and problems it might cost to actually try and make it so that in 2 generations we have an open source version of something that we can do now. And so I'd love to see it open source. I'd love to see an open source rocket that can do that. Absolutely. But I question whether it's the most viable thing to do as humans. Sorry.
So I don't want to answer the question, but
Yeah, well,
one of 3.
I think I'd like to expound on that a little bit, right? I think that, I think there are very viable questions about whether or not that's actually a good idea and on what scale, maybe. But I think also in the rocket science is not the hard part realm is the failure of imagination that I think often occurs around these things. I think the half-cat rocketry is a great example of a rocketry project by 2 people who have done this liquid bipropellant rocket it was thought to be this, amateurs just can't do this, so difficult, super expensive, impractical, and two people have changed our point of view on that. And similarly, that's part of what Lander Challenge is trying to do with self-landing rockets and rockets that are more advanced by college students. The fundamental belief is that they should be able to do this, and we're providing a framework for them to do that. But that is just as much a cultural project as that is a rocket science project.
Well, and along those lines, one of the big points of open sourcing this is not so that we can say we have open source Leo. I mean, sure, cool. But the big deal here is, back to what you were talking about, is the kind of other vector off of it is this idea, this very truth that if any one of us in this room wanted to start a launch vehicle business, the first thing we do is we spend about the first decade of time and money and resources reinventing the 1950s and the late 50s to early 60s. Why? Because all of this stuff is locked behind 17 levels of secrecy. And some of it is understandable. I mean, I work in that space professionally. I understand the implications, but at some point we will have to accept that Pandora's box needs to be opened, and we'll have to deal with the consequence of that, because we can't, as a species, afford to, every time someone thinks they have an incrementally better idea about launch or other things to do with spaceflight, that the first thing they have to do is redo the work of the late 50s to early 60s. That is a ridiculous ante to come and sit down at the table. It is literally billions of dollars and tens of thousands of production hours that shouldn't be respent. Imagine if instead of every time we wanted to do a new business like that, we didn't have to respend all of those resources. How much better off we would be as a species in terms of not pouring unnecessary resources away. That's why to open source it, not to accomplish an open source tick on the checklist.
Yeah, absolutely. Just sort of as an aside, I was just sat here thinking that, when I got into rocketry maybe 10 years ago, like the Kármán line hadn't really been broken by amateurs. And now there are just the other month, New Zealand Rocketry Club on South Island broke Kármán line, Dare have broken Kármán line. No, maybe not.
So real quick, for those
Kármán line, 100 kilometers,
why does it matter?
definition of proper space, not near space.
Yes.
So, now in 10 years, we've seen like that not be a thing that people can do to a thing that people can do. So, stuff does move in the right direction.
Those weren't Rocket Lab guys on the weekend, were they? Good question. All right. Does anyone have any questions here? All right. In back. I'll get my workout today.
So I don't know much about the sort of open source rocketry space, and I don't know much about the materials that you use, but do you think it would be possible with the advances in 3D printing to have a fully 3D printable rocket that can withstand space temperatures and conditions, considering we are having advancements in carbon fiber being printed, advancements in metal being printed? Do you think that would be a possibility in the next maybe 10 years?
Back down.
So my mind flashed back to about 4 years ago. I went to STEC, which is the European Space Engineers Technical Engineering Centre, for a additive manufacturing workshop. And what blew my mind there was actually, so I'm going to take 3D printing in the broadest term and include like laser sintering and all that, not fused filament sort of stuff. But I think most of the technology exists already. I think one of the big challenges that I didn't know anything about, but I came away from there, I was like, oh shit, right, okay. One of the big challenges is like So for like laser sintering, the qualification tools don't exist. So you can make this crazy, like you can build an amazing thing, but the testing tools haven't quite caught up. And the other thing is like quality assurance of materials. So like powders for laser sintered like stuff are really variable because essentially parts of it are like quarried and parts of it are chemically manufactured. And I think so. Like the sort of the technology is there, but the services to that technology are maybe not there. But I'm a bit out of date. But I imagine it's coming. There was a great guy who had this slide, right? And they were making I don't know what rocket it was for, but they were making a fuel tank, and he showed like the world's biggest freaking truck with a billet of titanium on it that was like, tons and tons, massive. It was like, way bigger than this room. And he said, we trepanned most of that out and made it sweepings on the floor. And he was like, that's why this is important. Like that, it's like millions and millions of dollars that we drill out of things to make fine metal tanks and stuff that will survive. And so it's not open source aren't going to push that particularly, but the industry is going to push to make that happen because it's just a far more effective way to do it. So I say 10 years. Definitely.
I think it depends. I'm gonna pivot a little bit off of that because I think part of it is that there is an assumption that some of these what feel like more advanced manufacturing techniques, which are actually old enough that a lot of patents have fallen out, so they're not as new as we think they are. They're just new to us because we now have access to them as smaller businesses are producing tools in that venue. That there is a perception that because of that newness that we are getting better in some way. Some of the material properties are not better. In fact, they're quite worse, and they're fundamentally worse because the molecular bonds are not there in the way that they are in other manufacturing techniques. They are more efficient. Like that, it's absolutely true. When you are doing milled parts, which is a very common manufacturing technique, there's far more waste than there is product, especially on ultra lightweight structures. And everything space is always ultra lightweight. If you've never heard of the tyranny of the rocket equation, it is math that just basically says we will be forever relegated to only barely being able to get to space as long as we're on chemical rocket propulsion. It is a tenuous thing to balance that equation. And it is terrible because we can see the stars, we can see that we should be able to get there, and we can only just. It doesn't get easier without a fundamental change in physics. And so everything's ultralight for a reason. And in places where we can get the right material properties through additive manufacturing or alternate manufacturing techniques, I think we will absolutely see a continued growth. But I don't think you will necessarily see an all additive manufactured vehicle. No, it wouldn't, because we live in such fine margins in space flight that the answer always has to come back to what gets me what I need that I can do. That's unfortunately the real ultimate deciding factor. And additive manufacturing will not be a holy grail, but we are absolutely seeing it create opportunities to create systems that were components of systems that were unfathomable, unimaginable a decade ago, for sure.
Sure. Well, I think there's one specific trend I'd like to speak to. I'm seeing it more and more in engines, specifically providing a performance advantage. The 50s and 60s technology for regenerative cooling and rocket engines is brazing or hand welding thousands and thousands and thousands of tubes together to make a rocket engine. You can now 3D print all of those channels much more quickly, much more economically, and with neutral or improved mass performance. So that has been used in multiple startups. I'm seeing it in the student competitions.
In some production.
Yeah.
There are 3D printed engine components, especially around cooling.
Yeah.
Absolutely.
So I think in engines in particular, it's already seen uptake and has provided a real advantage. In terms of how do I build a better giant tube, it has not shown the same strengths.
Do
funny that scales from like plastic 3D print, kind of, does it? Like, it's
Yeah.
really good for nose cones and little fins and things, but it's really bad for the tube.
Right. Well, and I found your description of it as an on-ramp to be pretty compelling of how people are acquiring 3D printers specifically to make their nose cones. That's their first interaction.
Well, do you think we are yet to see some sort of propellant or engine iteration out of the open source community that might be interesting? Or is it mainly derivative work yet?
Well, I think at the moment it's challenging to make derivative works because the library of information available is limited. And I think that's part of what the goal is to change, is to get to a baseline so that there is redevelopment and remixing and building on each other. I also think that a lot of the innovation in the amateur academic, single person, small team space is more about access, manufacturability, cost, teaching, simplicity type aims, which are all very valuable and noble, but are not necessarily maximum performance. And I think that's entirely acceptable and useful and something we should be working on, but it's just different.
Well, and back to that, I think we also have the challenge of the need to better reward and encourage open development. I applaud what your challenge is working on to promote universities to open the results of their research in a more complete way. This goes back also to the tooling and approach that we're developing at Mach 30 so that people don't have to figure out how to share when they do get around to going, I would like to share. Because when you are stuck having to figure out how to share, it's too much friction to overcome in an effective way. At that point, you do a data dump at the end and I shared. Can I check my box? And I think we have to, especially in the university settings where more compelling stretches of capability happen on average, not solely, clearly, but on average, the advancements happen there and in industry more often. And we're not going to get industry to open source right now. So if we can get academia to open source, that would be important to create an expectation at the leadership level that the right thing to do with the results is to not just publish a paper, but make public the repository that has every gory detail in it so that someone else can do derivative works. Because like you said, we don't even have the baseline for the derivative works yet.
Not sure I've got masses to add apart from my mind and my first sort of reaction to the question about if you make it sort of about propulsion rather than about rockets. I think it's quite interesting that you see, I don't know, is anybody aware of like the Michael Barretti's work, Ion Systems, which is completely open source, and the open source community has like sent him loads of money and high vacuum stuff to stick in his basement, which is kind of cool. So he's working on like micro thrusters for CubeSat scale and pocket cube scale stuff, looking at like pulse plasma things and all those different like kind of clever microwave ionized kind of propulsion systems. And it's like it's really cutting edge, and he's doing it in a way that is completely open and documented. I worry that he's going to burn out at some point, but so I think taking the rocketry thing out of it, I think propulsion wise, I think we will see true innovation coming from open source hardware, but not sure because of the problems we describe how we do that in that fragile bit of atmosphere in between.
Questions? Otherwise, I got one. But what do you guys got? Looks like you need tea or coffee. So it looks like for quite a while, open source hardware is going to be hitching a ride more than building a ride. what do you guys, what are your thoughts on making that process easier? I mean, I know CubeSat deployment has always been a little bit of a sticky problem. I'd be curious to hear what you think about that. Instead of answers.
So I loved this era when I was working for LibreSpace, so the brilliant thing about, like, if you are building an open source CubeSat, right, you've got a lot of friends, okay? If you're a lol academic open source CubeSat, you've got a lot of friends. And I used to go to, like, I'm not a very industry guy, you might have noticed. And I used to go to, like, UK, like, space agency events, and there'd be some startup talking about launching the rocket off the Shetland Islands, and yeah, we're going to charge like 100 grand a kilogram, and da 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 da. And I was like, mate, I'm like a guy in a shed in North Wales, and I can get you off the Canadarm off the ISS for $8,000. Like, I can literally ring him up and I can make that happen. Like, you've still got to do all the paperwork and all that. Like, you've got to do the hard bit, but, like, if you want the community guy to, like, introduce you, like, we can do that. So I think it's really accessible already if you are open source. But as soon as you start to put some, like, we're building this component and we want to flight validate it, and it's da 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 da, it's way back up in the prices again. So, like, it's there if you want it. If you want to get something on low Earth orbit, it's a bit trickier now because it's so busy up there, and things are tending to have to fly orbits below the International Space Station now, and have a big deorbit plan and all that kind of stuff. But it's absolutely there for the taking if you and achievable if you are prepared to work in a non-commercial and open source way.
I think it also partly depends on who you know. And I think extending that network to a wider audience is also important. Because I think that there are absolutely opportunities like that. But I've known other groups that have struggled to make those connections and gain access to resources like that because they don't know the right folks. And I think finding a way, there's a group that's got a table out there that talk about know how, know where, things like that. And I think identifying the network of resources of folks that are willing to play nice with open source, both from the perspective of, hey, we'll give you access to very expensive resources for very low cost because you're nonprofit in one way or another. Right? You're not trying to, as you said, flight qualify a piece of hardware kind of surreptitiously and then turn around and pump out these things for money. But also where expertise that you might not know that you need is hiding, right? And is willing to work with you. Be that in machining, be it in testing. The talk on testing I thought was really a good one yesterday. Because I do think that a lot of folks in both commercial and in open source don't think about that. And let me tell you, if you want to go to space, you usually only get one shot and you only have one copy. So you are rolling a lot of dice that do not like you. If you're a D&D'er, every one of them is cursed, and you are praying to the dice gods that things work out. And part of the way to buy that down and get better dice is to test within an inch of its life. And so putting that kind of thing into our brains and into our community and making testing an expected thing, I think would help too. Oh, again, some of us that are in industry, like we live and die by it, right? But out in the makerspace world, not so much, not always.
I agree, and I think that speaks to a larger point about your what is open source hardware question. Is a big part of this access and difference between success and failure is about methodology and process, and not necessarily the exact bit of physical matter that is in front of you that you're sending to space. I think a good design is always going to be the simplest design, and so it's often the thing that is actually going to space or is actually launching is rather simple, but it's very well defined, very well characterized, very well tested, has a specific set of goals that it's been optimized explicitly for. For example, for going to space, you're talking about the hard part is the paperwork, right? What are all of the things you have to show? What are the plans you have to make? Who are the right regulatory authorities? How do you get in touch with those people? If you're running a launch site, what are your procedures? Who are the civil aviation authorities you need to work with? What are your local regulations? How do you inspect people? How do you get people flowing through your launch site? There's a whole lot of methodology and process questions and output that I think are more important to success or failure than the particular object. And I think that needs to be developed and spread more widely in a community baseline.
Well, and I think an important follow-on to that, and the CubeSat launcher on the ISS has helped a little bit with this, but it isn't completely gone. We have to remember that when we are going along for a ride on somebody else's launch, invariably our payloads are not the primary mission. We are hitching a ride, right? We stuck our thumb out and somebody let us hang on to the back of the car, right? And it is essential that our hanging on to the back of the car does not endanger the primary payload. These things cost hundreds of millions of dollars. And if you want to know why even the CubeSats are being tested within an inch of their lives, it's because it doesn't take much of a failure anywhere in the payload section to create a very bad day for everyone's payload. Huh?
Like a tiny outgas.
Yeah, like like you said, tiny outgas, a small a nut coming off of a bolt and flying loose. Like these things, it takes very, very little. Again, back to you're rolling a lot of cursed dice, and no one wants to let your cursed dice roll with their cursed dice that they've been trying to get rid of. So the other piece of the thing, we have to remember that part of this is us playing nice with others that have a lot more at risk.
I always seem to come with the slight asides at the end, which seems my position in life. But I think you made a really interesting point about who you know and community stuff. And I suppose it's a plea, really. All of these stories that I've been involved in, I've kind of ended up being the community guy, being a gobby, brash, connecting people, pulling people who maybe feel a bit awkward into conversations with other people. And I think if you have that skill set, really consider trying to put that to use, because I don't want to stereotype and generalize, but there's a lot of people in these communities who find that incredibly difficult. And I've suddenly, over the years, I've realized that there's a huge power to putting that stuff in. And then the last thing is a silly anecdote about test equipment that I haven't thought about this for years. But before the first 4 Pocket Cubes launched, one of them was called Ren, built by a guy called Paul Casilla out of Aachen in Germany. And there was another team in the UK who were building one. And we realized that they would all have to do vibration testing. And University of Strathclyde was going to test some, and somewhere else was going to test another. But the sort of the clamp that we put the Pocket Cube in didn't exist, because it was like the first 4 that had ever been. And so I love this but this is it's a community connection, but it's so weird. I was involved in sharing the design. Paul Casilla worked in a CAD environment called OpenSCAD or OpenSCAD. Who knows OpenSCAD? So it's script based, yeah. So but he was working in a really open way. So this team in the UK wanted to see the model, and he text messaged it me. So he put it in WhatsApp, that's it. And so I had an open source Android app called ScorchCAD that could compile it and view it. And I was like, oh, okay, that works. So I copy and pasted the code for the vibration clamp jig into an email and sent it on to the other people in a lay-by near a castle in North Wales that was beautiful. And it's that thing of sometimes it's the most insignificant, would you share that with these guys? Yeah, it's here in a text message. Sure, okay, I'll forward it. But it, quite pivotal parts of the story come from just thinking about how you can make a connection between 2 complex things.
I'm going to ask you guys a tough question. Yeah, so solid and liquid rocket fuel, liquid oxygen. They're not things I have around the house because they're kind of danger chemicals that explode. You want them to control explode, but it's not always that lucky. You have to roll some dice. Should we be open sourcing all of this stuff? Because, you think that some other lab at some other university will go build your thing, but I'm crazy. I'll do that stuff at home. And I don't know what the heck I'm doing.
I feel duty bound as a resident of the UK to answer it first for the UK residents. So in the UK, it is completely illegal to develop your own solid rocket propellants. So when you see these hipster American cats boiling up their sugar candy on YouTube, that is a knock on the door here. And I also used to sit on the UK Rocketry Association. And, I'm a filthy anarchist at heart. I don't like, but there were times where even I was like, yeah, we need to tell the firearms guy in this county to just go and have a chat with this guy because, this shit, he's only got one finger left and, But in the UK, you can do liquid rockets. There's a part of so the UK Rocketry Association is our version of NAR or CAR, or I suppose a bit like EEE and things like that. So it's the governing body that advises government and looks after accreditations for amateur rocketry and a lot of student rocketry as well, high power rocketry. So yeah, we have people regularly experimenting with hybrid rocket engines and to a certain degree liquid rocket engines, and there is expertise and guidance and the construction of rules and systems around that. We have a safety and technical committee who will do some scrutiny with you and make sure that you're not just going to die instantly. You at least have to get 6 months into it now. So I agree. It is incredibly dangerous, and there are, but yeah, and the UK does look different from the US, but YouTube doesn't delineate those things. And so, yeah, I would urge everybody to stay safe and seek out help from people who know what they're doing. Really, that would be my plan.
So, as an American that has a story on the Sure motors, I want to weigh in on a couple of things. The first is YouTube is not the place to learn rocket science. I'm sorry. Okay. I was running an event. It was kind of like a space-oriented mini maker fair. And one of the demos was a little sugar home done rocket candy kind of thing. And predominantly, it was by a gentleman that was in industry, and I thought he knew better. And we did a rehearsal of it, and it was fine. This was in an indoor space that had professional grade welding ventilation gear. The space had approved, as long as the ventilation gear was running, we could do this. We go and do the first demo. The ventilation is running. He went and did the second demo without doing the proper notifications up the chain of command to get the ventilation running. We evacuated an entire mall. We were visited by 3 fire trucks and the feds, and almost got the space shut down by the feds because this stuff is dangerous. No one was hurt. It was just a bunch of smoke. Wasn't even a lot of fire. But it set off the kinds of alarms close enough to the White House, because it was just outside the District of Columbia, that the feds were very concerned about what was going on that day. Seriously. Open sourcing this stuff is different than YouTube. And part of why we are so focused on describing what the source is and what complete open sourcing is and things like that is because when you move from little Arduino robots to things like rocket motors and rocket engines, your source needs to be complete, including fully defined and understandable safety processes and protocols, because that is the difference. That completeness with the safety stuff and the proper warnings, right, is what sets it apart from I saw a thing on YouTube. Because then if you are diligent and you respect the system in question, you can get rid of some of those scary cursed dice and operate in a more secure mode. So I would say these are things people are going to do no matter what. Case in point, right? Stories that we both have just shared. I would rather they do them with complete description of how to do them safely and with stuff that has been verified by experts than they saw it on YouTube.
Be safe.
Having been an undergraduate, I can attest to this.
But I think that this also speaks to some, certainly a trend going on in the US right now around the liquid rocketry. You mentioned liquid oxygen specifically, which actually is viewed as one of the safer options.
It's
You know,
cold and pretty reactive as opposed to caustic.
yeah, as opposed to some other red fuming nitric acid or high test peroxide or other very nasty things. Yes. I think that an area,
That's an entire history of dangerous things to burn.
yeah, that's some work from the 60s that I would prefer not to reproduce.
Lessons learned.
I think that an area of focus right now, or in the US, liquid rocketry is becoming more and more prevalent. Part of it is coming from the demand side of industry is much more interested in this. So as you work your way back through career development, it's now come down to college students who are very interested in this. We, as Lander Challenge, saw this and explicitly made that a requirement. It is half-cat rocketry. I'm going to return to them as an example, is doing it on an individual amateur level. So on the demand side, there's a lot more demand for this and people actually doing this than there was even 5-10 years ago. I think where there's a huge hole right now is there is not a minimum accepted set of safety standards for how to do this. I think there are people doing it successfully and people doing it in a mature or professional manner, but there is not one unified set of safety standards about this the way there is with solid propellants. And so I think it could even be an extremely restrictive, narrow set of rules, but there's not even consensus around that right now. And I think that is something that as a community, an open source community, or as a maker rocket community generally, is a key missing ingredient that would serve us all well to develop so that we're starting from a baseline safety standard that's easy to communicate to everyone all the time and is not an artisanal, something I've learned from someone else way. Exactly. I think that I think it is true that YouTube is not a complete education on how to do pyrotechnics safely. And I think the canonical advice you receive when you ask about it is go talk to someone who's expert. That is true. That is good. That is an individual person's experience that is not coming from a universally accepted baseline. And once you have that baseline, then you start being able to do institutional things like we have some sort of club or chapter system, or we have a national rocketry organization, or we're able to purchase insurance, or we're able to speak to our state and federal regulators. Or exactly.
Well, and going back to that, part of the reason that we started with that very, very, very small scale rocket test stand is that it gave us the opportunity to drill into volunteers the idea that safety protocols matter always. And you do not get to fire this thing up until you understand the safety protocols, can demonstrate that you can execute the safety protocols. And the really good news was, this is not the kind of thing that if you made a mistake, it would cost you lives. It would hurt you. And I don't want you hurt, but I would much rather you practice on something that will hurt you if you do it wrong, like a burn, than a thing that will cost you limbs or might kill somebody else because you weren't doing it right. And I think that gets back to part of that certification idea in following with how NAR and Tripoli and similar groups do, that you don't get access to more dangerous things until you have properly demonstrated that you can do the less dangerous thing correctly and well.
Weirdly, though, all the sort of stuff about bringing academic teams into our amateur rocketry world is about fast tracking that. So I've often noticed there's like systems in the UK and there's systems in the US that would allow, like as an individual, I have to do various types of flight and they increment up to get various high power certificates and to be allowed to buy, like physically the vendor to be allowed to sell me the bigger engine that I want for my next rocket. But a lot of the sort of systems around getting academic teams and university teams to kind of do rocketry about how do you get a group of 30 people to bypass some part of that journey? And that's really interesting because it throws up, I've probably seen more dangerous stuff in the academic rocketry where, you know, things that could have been picked off with like the smallest model. So like, I remember being a S&T member, so observing a university rocketry team and seeing somebody wrap a load of shroud lines around a parachute, which is kind of what it says to do in the Estes model rocket thing, and it's wrong there as well. And so like I looked at it and I was like, that's going to come out and stay as a ball in the sky and not become a parachute. That's going to be like a pom-pom in the air. And thinking like, yeah, that's a real symptom of we've cut past various stages, you know. And so I think sometimes systemically we build the danger back in at times.
I think I also want to level set people on how risky rocketry actually is. I think when you look at the injury and fatality rates, it's low. And I guess it's not quite zero, but it's, I think in the US, it's 1 fatality over 50 years or something. I think I saw a comparison to bowling once. Don't hold me to that comparison, but when I've gone through the risk management exercise in a institutional context around rocketry for using, the conclusion has always been that the multi-hour drive to and from the launch site is riskier than the launch itself. Now, that is a testament to all of the procedure, design, culture, safety culture that has been developed over many years. So I think that is no accident, and that must be continued and preserved as we scale up, right? Including as the propulsion technology changes, and that's fundamentally difficult to bootstrap. I mean, a bootstrapping problem just takes time and iteration. But I do want to level set the level of fear around it, that I don't think it is something that people need to be, they need to appropriately respect, but need not be full of fear.
Yeah, absolutely. I think that point is, as long as you are following those processes and procedures. It gets scary when all you have is YouTube, as an example.
All right, so no YOLO building from YouTube videos. Please avoid that. You go.
So I'm very guilty here because I follow YouTubers like BP.space, for example. They make like rockets, thrust vector control style rockets and things like that. So you've mentioned a lot about safety. So question is, as somebody who went to university, I didn't study like mechanical engineering. Tripoli is what I studied. So where can I get started, and where can I get started safely?
So the answer is always, I think, find your local rocketry club. That's where I think probably we would all rally around that. Yeah. Find your local rocketry club. I know in my intro it was mentioned I was in the Flame Trench with Joe Barlad, who is BP Space. And so like Joe is, he's studied media, so his YouTube's really good, and his rocketry is really good. But he is he is interacting with stuff. So like he has gone to Narcon and done talks. His bigger stuff where he's built like big solid rocket motors. He's doing the FAR with Rick, and like so he is engaging with the systems that are there. It's just it maybe makes it look a bit more standalone in the YouTube. But it fascinates me because I think Joe Barnard is like single-handedly responsible for like a generation of younger rocketry people, certainly turning up to UK rocketry events and talking about the stuff that he's done. And yet, like when you talk to Joe, he's a bit like when I talk to Copenhagen suborbitals, if you know them, they've become like, they're more like they're content creators first now. I mean, so Copenhagen suborbital would argue against that, but like they don't get donations if they don't create content, and it definitely puts a different slant on it. And so, like, I totally agree with my colleagues. Like, YouTube is not the place to learn rocketry, but it is often the most visible on ramp for people wanting to join this community. So yeah. But your rocket club. And like start small, man. Like people get all excited about burning loads of money in something big as soon as they can, and when you've been in it a few years, you realize like there's like building a small little thing that does like exactly what you want it to do, and you measure where it gets to, and like there's a lot of fun and challenge and learning in that totally scales up.
I don't have anything to add other than know who your local like affiliated with following the regulations rocket clubs are, right? No NAR or Tripoli, or what's the one in the UK again? UKRA, right? Be sure that you're connecting with those groups and their local chapters, not the local group of YouTube followers. Because I think there are a little bit of that starting to, like, people don't know where the legit is. So just make sure you find the legit. Is that fair? I'm gonna what?
I was just going to recommend there are some pretty good Discords.
How do you tell what is a good Discord?
Well, like, right.
Now you've done it. Like you stepped right in that one.
Right. Well, yeah, of course. Yes. Thank you. Thank you. Yes, my Discord. I mean, the Lander Challenge has a Discord. Also, the Reddit Our Rocketry has, but it's a Reddit also with a Discord that has a lively bunch in it. That I think it is very important when you're getting started to make sure you are having fun and to be building personal relationships. Like humans are social creatures that get benefit from interacting with other people doing the same thing. And so a lot of that community can be had online. And I think in that sense, it's very relevant. And I see lots of interesting and wacky ideas being generated and refined online that eventually come to pass, and wild and wacky rockets that fly successfully for great fun and make great YouTube content. I think the admonitions about safety are especially relevant for making your own propellant, which again is not even possible in the UK, and it is possible in the US. But rocket fuel is a combined fuel and oxidizer at the same place. It is ready to burn all of the time, right? And so that's fundamentally hazardous. A lot of the safety at a rocket launch occurs from just making sure you're standing a half mile away when you press the button, right? And so I think at some of the university rocket competitions, they stand everyone very far away, and they rigorously check it, but ultimately failure is part of the process, and many rockets will fail. And part of the setup of a launch is ensuring that failure can occur safely. It absolutely will happen, and it's part of the spectacle. It's very exciting when it happens, and somebody is learning something that day. It might be you, it might be someone else. Hopefully, it was for a reason that's a good learning opportunity, and not something where you just smack your forehead and say, I forgot to attach the parachute. or something. But that happens too. That happens too. Yeah, that's one too. Duct tape is not a structural adhesive. So I think that ultimately launching things requires doing things in person. I think you want to find those people and have fun with those people. You want to make sure you are having fun and picking a scope of project that you can actually finish and is enjoyable. I think a lot of people get more satisfaction out of launching one rocket many times than working for many months and years to launch once. Or not launch at all. And the online communities are great for developing the human aspect, for getting ideas and learning some things. Ultimately, you have to do the in-person part safely.
You asked yes to all of that, and you asked, well, how will I know, right? And there are well-known ones, and you name, like, our rocketry is absolutely full of the kind of people that I would want you to learn from. The thing to look for is when someone proposes something that is clearly unsafe, that the community comes in immediately and steps up and checks that, right? When something that is clearly unsafe and everyone goes, do it, you are not in the right Discord. Okay, there are, I'm sure, those Discords. I do not hang out on them, so I cannot tell you which ones. But that's one of the things to look for. And it is perfectly cool and fine and can be safe to turn your Christmas tree into a rocket. And there are plenty of YouTube videos of it. There are plenty of people that do this at the end of every year at the local launch communities because it is just a thing. It is cool. I'm not saying don't do cool things. I'm saying look for the places where people go, yes, and this is the thing you need to keep in mind, not, yeah.
Absolutely. This, I suppose, if you're new to rocketry, the thing that you maybe don't get until you've done a bit is finding what's cool for you. So some people just buy kits and build kits and launch them, and they want to make them look like they look like on the box, and that's beautiful, man. There are people who want to do scale modeling. There are sports competitions with different challenges. Do you know what mine is? It's ridiculous. I never dreamt I would get to this. Rocketry has been the gateway drug for sewing machines for me. I'm obsessed with recovery systems. I've written code to help me generate the patterns for the gauze for the annular parachutes that I do based off the work of TK Kanaka. You know, like I'm into building parachutes now. So I own like two really high. I've got an overlocker. I've got like a bar tack machine. I've got like a computer. Like, it's crazy. And I talk more about parachutes. The whole computational fluid dynamics thing I learned because my mate who's in Copenhagen suborbitals, which is not open source, but they're aiming to do a crewed mission to space as an amateur donation-led organization, is designing a high-entry balut parachute. And they've tested it in, they've been to TU Delft, and they've tested it in the quite expensive to hire wind tunnel. And he was like, oh, if I could CFD this, it'd be useful to blast through iterations. So, like, where it takes you can be way away from where you start. Sorry.
Yeah, I didn't think that I would be caring about the file formats used to exchange design information when I got into spaceflight. Speaking of bizarre places to wind up spending all of your mental energy. So yeah. And
Sure, and I think I've really enjoyed some of the organization building around this, kind of doing the export control or doing the media for the rocket competition. I really enjoy getting to see everyone else's rocket fly. It's fun for me whether it succeeds or shreds into 1,000 pieces. And though I have also gotten into the parachute making. I think we might have some more to talk about later.
So I'm supposed to let you guys wrap. Well, first, let's give them a round of applause. This has been wonderful.